Hello guys, welcome you all for this end-to-end session on AIML where you guys gonna learn everything in order to become a successful data scientist. Hope you guys are enjoying guys. So I'm learning a lot. So we are enjoying and we are learning a lot each and every day. So hope the same thing for you guys. So today we're gonna look into a theory concept of one of the clustering technique, that is hierarchical clustering. So guys, as always, as I mentioned, right, before coming to the session, make sure that you guys watch all the previous session videos so that you can have a better understanding of what we are talking. So yeah guys, so last 2 to 3 session we have introduced you to a concept called as k-means clustering. It is one of the very popular clustering technique that comes under the unsupervised learning, and we have discussed its black box theory concept and the coding part of it. Okay, today we're going to see one more clustering technique, that is hierarchical clustering. I will say it is uh, somewhat less used when compared to k-means, but it also has a greater application. Okay, so let's without wasting any time, let us jump into today's session. So today's session is all about a theoretical concept and black box of hierarchical clustering. So what is hierarchical clustering? Hierarchical clustering is a powerful technique for grouping similar data points together. It forms a hierarchy of clusters, starting with individual data points and merging or splitting clusters based on their similarity. This method is widely used in data analytics, machine learning, and various scientific disciplines. Okay, guys, anything which is related to cluster, it gonna combine the data points which has a similarity. That's it. Okay, here this hierarchical clustering is also the same thing, but it will follow a tree structure. Whether it can be a top down or bottom up, it's gonna follow a tree structure. Okay, just understand this. Okay, so yes sir, over to you. Yeah, so this is all about like what is hierarchical clustering. Okay, so sir, is there anything that you need to add, sir?
Yeah, so hierarchical clustering, we have to understand, we'll go deeper into it, a comprehensive guide. So, hierarchical clustering is a powerful technique for grouping similar data into uh, points together. Okay, so it works in hierarchy, guys. So, if you know that in hierarchy, we use decision trees, right? So, that's the algorithm we use. So there's an hierarchy. It forms a hierarchy of clusters. Okay, there are different clusters in hierarchy, starting with individual data points and merging or splitting clusters based on similarity. Again, there would be a similarity based on there should be a similarity in the cluster. Otherwise, there is no need to do that because similarity is the main objective. In the cluster, you need to have similarity. Okay, the method is widely used for data analysis, machine learning, and various scientific disciplines. So, this has a very good use in AIML. So, guys, learn all these sessions. If you have come to this session, so go watch 5 to 10 times the previous sessions and understand the application, absorb the information, digest the information, and apply. And build a long-term objective function for your career. And also have patience, perseverance, persistence, and consistency with this architect of learning. Build long-term vision and skills. Okay, and write in the comment section what have you learned. If you have any feedback, so you can give us. We are ready to implement and improve if they are genuine and implementable ideas. We'll do that. So keep learning deeply. Thanks.
Yeah guys, so let us move on to the next slide. Okay, yeah, what are the fundamentals of hierarchical clustering? So let's see what builds this hierarchical clustering. One is proximity matrix, another one is dendrogram. I will say this is a major thing. Okay, next distance matrix. Next is cluster formation. Let's see one by one. Proximity matrix. Hierarchical clustering relies on a proximity matrix that measures the similarity or dissimilarity between the data points. This matrix serves as a foundation for constructing the hierarchical structure of the clusters. Okay, you know matrix, right, guys? Simple, right? Rows and columns. So we will be having a values in a rows and columns format. These values are very important for us to build this hierarchical clustering. That is what called as proximity matrix. Dendrogram. Dendrogram is a graphical representation of hierarchical clustering process. It visualizes or the merging or splitting of clusters at different levels of similarity. So what does dendrogram will do means it's like a tree-like structure. Okay, it will say how many clusters the data points will have. It's a simple thing. You need to apply a dendrogram and get the number of clusters. Guys, I hope I'm going to mention something. If you guys watched our videos, previous session videos, then you guys can able to understand. WCSS, that is within cluster sum of square. Elbow method, which helps to find number of clusters in k-means. Similarly, for hierarchical clustering, we use dendrogram to find the number of clusters. Okay, perfect, right? If you guys doesn't able to understand that WCSS, then it's not not the thing. Like because like it is already taught to you in the last 2 to 3 sessions. Okay, so hope you guys just go through it so that you can have a better understanding of what this dendrogram for hierarchical clustering. When you understand elbow method for k-means clustering or WCSS, both are same, right? Okay, so moving on, let us discuss this distance matrix. Choosing an appropriate distance matrix is crucial for measuring the similarity between data points. Different metrics such as Euclidean distance or Manhattan distance may result in varying clustering outcomes. Yeah, that's true. So, whenever you are having a data set, you need to try with different kind of distance metrics and find which different from the different distance metrics, find which one fits your data set and try to use it. Okay, most commonly used is Euclidean distance that will be fitable for all kind of applications. Okay, let's move on to the next thing. Like we are having cluster formation, right? Hierarchical clustering proceeds by iteratively merging or splitting clusters based on their similarities or dissimilarities as defined by the distance matrix and the choice of linkage method. Okay, don't worry about this linkage method. Linkage method is a simple thing. Whenever you are splitting, right, how you are splitting based on the linkage method, and you will be splitting based on the distance also. Okay, if two data are closer to each other, you will form a cluster. When they are far away based on the distance, then you just split it to different clusters. Okay, hope you guys can understand. These are the fundamentals of hierarchical clustering. Guys, make sure that you understand these things because like these are the black boxes of hierarchical clustering. That is this algorithm. So when we are moving on to the coding part, right, it will be very helpful for you because like again I'm mentioning only 2 lines of code. Okay, so that's the thing. Yes, sir. Over to you.
Yeah, fundamentals of hierarchical clustering. First element is proximity matrix. Matrix, guys, it needs to have two dimensions. Yeah, two-dimensional array, you call it matrix, okay? So array in two dimensions, okay? So that is what is matrix, okay? So hierarchical clustering is it relies on proximity matrix that measures the similarity or dissimilarity between data points. So similarity or dissimilarity, okay? It measures that. This matrix serves as a foundation for constructing hierarchical structure, okay, of clusters. So this is what proximity matrix is used. The dendrogram is a graphical representation. Okay, you might have seen dendroids in neuron, okay, or you have seen in neural network, you'll see dendroids. The word comes from there. The That's why it's like graphical hierarchical clustering process. It visualizes the merging of splitting of clusters at different levels of similarity. Okay, so dendrogram is that, and then we have distance matrix. So distance matrix is um, this is again a matrix which will be helping in terms of the distance. Okay, in the clustering, the distance between the matrix. Okay, So then we have clusters formation. So this would be like how to form the clusters. Okay. Hierarchical clustering proceeds to iteratively merge split clusters based on their similarity and define the distance matrix and the chosen linkage method. So this is the cluster formation. This is how it is done. Okay. And as I said, distance metric is like it is choosing appropriate distance matrix is crucial for measuring the similarity between data points. Distance metrics such as Euclidean distance or Manhattan distance may result in varying clustering outcomes. So these are the four elements of clustering, okay, and clustering metrics, like fundamentals of hierarchical clustering. So these are the four. One is proximity metrics, dendrogram, distance metric, and cluster formation. So these elements form the hierarchical clustering. So we use these techniques to make hierarchical clustering. So yeah, these are the fundamental elements of hierarchical clustering. Let's move to the other section.
Yeah, sure, sir. Let's see. Guys, next thing. Agglomerative and divisive clustering. It's a simple thing. Guys, make sure that you understand. That's the only thing. Because like when I start to learn, right, I will be getting confusion in this terminologies. Okay. Let's see. Agglomerative clustering is a bottom-up approach that starts with the individual data points, merge them into progressive large clusters based on their similarity. This method is often called as agglomerative hierarchical clustering, which start with the individual data points. We group them and becomes a larger cluster. That is what called as agglomerative clustering, agglomerative hierarchical clustering. Divisive clustering is a top-down approach that starts from all the data points in a single cluster, recursively splitting into smaller clusters based on dissimilarities. This method is less common than agglomerative clustering. Okay, what is divisive clustering? We start with the larger cluster, split them based on dissimilarities, and we end up with individual data points. That's it. Okay. Agglomerative means it is bottom up, single data points to the entire whole cluster. Whereas divisive clustering is entire whole cluster to single data points. Okay. Hope you guys can able to understand. Okay. Never ever just forget this, because like in interviews they will ask these questions, because like what are the two types of clustering, hierarchical clustering you are having? Agglomerative, divisive. Agglomerative means it is bottom up, whereas divisive means it's top down. Okay. Hope you guys can able to understand. Yes, sir. Over to you.
So agglomerative and decisive clustering is, guys. So these are two very important clustering techniques. So agglomerative clustering is bottom up approach, okay, and decisive is top down approach. So this is the main similarity and dissimilarity of these clustering, okay, techniques. So agglomerative is that it starts with an individual data points and merges them into a progressively large clusters based on similarity. This method is often referred as agglomerative hierarchical clustering. Okay, then we have decisive clustering, which is like top-down approach that starts with all data points into single cluster, recursively splits it into similar clusters based on dissimilarity. This method is less common than agglomerative clustering. So these are two techniques of clustering. We need to deeply understand them and apply wherever required as per data characteristics and as per the problem statement and the objective function what you want to achieve. Let's move to the other section.
Yeah, sure, sir. Let's see what we are having next. Okay. Okay, we have learned about linkage, right? Let's see what is linkage. Linkage methods in hierarchical clustering. There are multiple linkage methods. Let's just see one by one. Single linkage merges clusters based on the minimum distance between any 2 points in different clusters. Okay, we will merge the data points if they are as the minimum distance. That is called a single linkage. What is meant by complete linkage? Merges clusters based on the maximum distance between any two data points in different clusters. Okay, here we merge the data set which has the maximum distance. Average linkage, it merges the clusters based on the average distance between all pairs of points in different clusters. Okay, here merging occurs based on the average values. Centroid linkage merges clusters based on the distance between the centroids of the clusters. Okay, based on the centroid that we are having in each and cluster, we will merge them. Watts cluster merges cluster that minimize the increase in within cluster variance. Okay, so we are having data points within a cluster, right? So whenever it has lesser within cluster variance, whenever there is an increase in within cluster variance, so whenever you are having more variance, right, then you will merge it up. That is called as Watts linkage. Okay, so I hope like you guys can able to understand. Single means minimum distance between 2 points merging. Complete means maximum distance between 2 points merging. Average means merging based on the average distance between 2 points to merge. Okay. Centroid, based on the distance between the centroid of each and every cluster, we merge. Watts linkage, where we minimize the increase in within cluster variance. So whenever there is a less variance in within cluster data points, then we will merge them. Okay. I hope like these are the 5 linkage method that we are having in hierarchical clustering and how to merge your data set. Okay, so yeah, sir, over to you.
So linkage method in hierarchical clustering, we have linkage method. Okay, so then uh, we have description of it. So linkage method is merge cluster based on the minimum distance between any 2 points in different clusters. Okay, so what it means is uh, it merges clusters based on minimum distance between 2 points in different clusters. Okay, so this is what is single linkage. Okay, single linkage is defined this way. And then we have complete linkage, which is merges clusters based on the maximum distance between 2 points in different clusters. So single is minimum distance. It will in two different clusters it will merge. Okay, it merges. And then complete is the maximum. Okay, this is how you remember this. uh, Complete is the maximum, the cluster based on the maximum distance between 2 points. Okay, in different clusters. Then we have average linkage, which is the merges clusters based on the average distance between all pairs of the points in different clusters. So again, average is the main keyword which you have to remember. The average distance between. Okay, in single it is the minimum, in complete it is the maximum distance, and in average it is the average distance between two clustering different clusters. Okay, points, distance between pairs of points in different clusters. Okay, then centroid is merges clusters based on the distance between centroids of the cluster. Simple. So based on the centroids it will merge. Okay, then we have Watts linkage, which is merges clusters that minimize the increase in within cluster variance. So that is the last linkage. Okay, which will happen. Watts linkage is that it is merges the clusters that minimize the increase within cluster variance. Okay, so it focuses on that. Okay, so this is all about the linkage. Okay, different linkage methods in hierarchical clustering. So remember these concepts deeply so that when we go for application, so you can use it, you know why we're using, how we're using, what are the limitations. Deeply understand all these concepts. Okay, keep learning.
Yeah, guys. So these are the linkage method that we are having for hierarchical clustering. Guys, we will pass here. Okay, so we will continue in the next session. Guys, till now we have just introduced you what is hierarchical clustering, what are the things that is inside it, what are the basic concept, what are the linkage factor, what are the types in hierarchical clustering. Hope you guys have enjoyed. So keep learning, guys, keep learning, and if you have any questions, just let us know, ping in the comment section. We will take up and we will solve your doubts. We are here to help you, guys. That's the only motto for yours. We will be helping you to achieve what you need. Okay, related to this field of data science. Okay, so yeah, guys, uh, that's all for today's session. We will all meet in the next session. Until then, bye, guys. Take care. We will all meet in the next session. Bye.
Hi guys, go and watch all the sessions 5 to 10 times. If you have not subscribed to our channel, also go and subscribe and press the bell icon so that you will get notification, and keep learning deeply with patience, consistency, persistency and perseverance, and long-term objective function of your career. And write us if you have any feedback, any improvements, and do all the quizzes, assignments and projects. Keep learning deeply. Thanks.